Yes. So I'll just put one more tab here and I will put PQ doubts. Yes, Kaustubh, you had a doubt, right? Go ahead.
Yes, sir. Yes. I have sent the question in chat.
Okay.
So in the first part, we'll have to define the different forms. That is okay. There are two scenarios which are given to us. First one is clear that the share price falls suddenly immediately after news of an earthquake. Means there is a public information and the market has reacted to that.
Ah,
But the second scenario is not clear because it mentions company's share price falls suddenly when a long awaited and publicly negotiated merger is completed. So what I interpreted is that the merger is long awaited and publicly negotiated. Like public already have the information.
correct.
And, and then the price falls suddenly. I did not really understand that.
Anyone else has a similar doubt? So that basically means you don't have, na? Then we'll ask someone, na?
I also had this doubt.
Okay. Anyone wants to give it a shot before we start discussing? I've copy pasted the question on the screen, so I think that will work. Anyone? So guys, first important thing is this is an example of an anomaly. Yeah. So when we were doing anomalies, okay, so testing for EMH, when we had done underperformance, we had discussed that two companies, whenever a merger happens, there is fall post a merger. So what happens is typically people tend to estimate, incorrectly estimate the benefits of a merger. Okay. So synergy benefits are estimated to be higher, but practically when things work out, synergy benefits take a lot of time to get really benefited in the financial statements. So what happens post a merger? There is a sudden fall. Okay, there is a price correction that happens that comes back to an original value. Even if you look at the example of HDFC Bank and HDFC that we discussed, till date, only yesterday HDFC Bank announced, I think on Saturday they announced their results. Till date, they are having problems of HDFC not being solved. The synergy benefits are still coming in. So they are expecting that in the next 1 year, all of the synergy benefits will come in and the balance sheet will start making proper profits as it was earlier. Okay. So to answer this is basically an anomaly. There is nothing. So we go ahead with our questions that were there first. Our price is random. Nothing is mentioned about price not being random. So we'll assume it to be random. Now this is publicly available information. Okay. But the market did not price it correctly. Okay. So there is a temporary difference, which is inconsistent with the semi-strong form. Clear? So the answer to this is it is consistent with weak. But inconsistent or temporarily inconsistent with the semi-strong form. It is an anomaly. Clear?
Yes, clear, clear. Thank you.
Any other doubts, guys? Good.
So, but in this one, if we put that it is a consistent with weak form of EMH, but inconsistent with the semi-strong, but we don't put the anomaly one
That's
apart.
fine. That's fine. Ideally, you should highlight it because remember when I was telling you that typically identification questions will have anomalies. Whatever
Yes.
6 anomalies that we discussed typically will come as identification questions. So it's important for you to remember those anomalies.
Okay, sir.
Okay. Cool. Okay, Riaz.
So I didn't understand what the question is asking about.
Cool. Chalo. Just zoom in. Yeah. State two reasons why it is hard to test whether any of the three forms hold in practice. So, guys, you remember when we discussed testing of EMH, how to test? Okay, there is no direct testing. You guys must have observed, Ria, I didn't tell you okay, you directly test it. You test it indirectly. Okay, and market prices fluctuate so much in a day that it becomes very difficult to actually test over a period of time. So अपन ने negative approach adopt किया है. In this, what do we do? अगर कोई टेक्निकल एनालिसिस से पैसा बना सकता है तो बेसिकली मींस के वीक फॉर्म एफिशिएंट नहीं है. We didn't actually test whether the past information was in the price. We used a negative testing approach. Clear, Ria?
Yes.
So practically, let's put this down. Practically, the problem with testing is that there is no mechanism to ascertain whether a particular information is in the price. Second important problem is that prices fluctuate a lot due to demand and supply reasons. Okay. So that is the reason why you adopt a negative testing approach. You can also put the examples of anomalies. There are certain periods of time, not put the entire example, but just there are certain periods of time where prices don't incorporate information, but it is for a temporary period of time. Clear, Ria?
Yes, sir.
हाँ, practically test करना impossible है. ये तो we have taken a negative sense of approach. Cool. I go ahead with your next chapter then, which is utility theory. And this is specifically in finance. Okay. So now, ideally, the concept of utility theory is what we have already done in economics, but that is done to understand consumer behavior. We will stretch that same theory to finance, but our aim will not be to understand consumer behavior. Our aim will be to understand investor behavior. Okay. So the same theory that was there in economics gets converted to finance. Instead of looking at consumer behavior, we will be looking at investor behavior. Okay. This is a bigger chapter. Okay. And there are good amount of questions that come from this chapter. I think if anyone's gone through the PQs, you must have realized that there are a large number of questions coming from utility theory. Okay. So before I go ahead, I think we need to recap consumer utility. You just completed it, right? So this is not there per se for PTSA. This is purely there, was there in economics. I'm just recapping it so that I can draw parallels with what is there in utility and how do you use it in finance. So, guys, how do you define utility in economics? Anyone? You guys have just done.
The want satisfying power of a commodity.
Very good. So, utility is basically the satisfaction that you derive from consumption of a good or a service. Okay. In utility theory, we assume that this satisfaction can be measured. Cool. What else did we learn in utility theory? So this is the first thing. What's the second thing that we learned in utility theory? Anyone? This is talking about consumption, nothing about finance. We have done this in economics.
That as and when we consume more of a product, the utility tends to diminish. So, like the law of diminishing marginal utility.
Very good. The second important thing we did that we did the law of diminishing marginal utility. I'm using an abbreviation DMU, okay, which is diminishing marginal utility, which basically says as we consume more of a good or a service, the marginal utility diminishes. And I hope everyone understands marginal. Marginal is basically the additional utility. The total utility increases, but the additional utility decreases. So just to give an example, let's have good X. When I consumed 1, the utility that I derive was 10. When I consumed 1 more, let's say it became 18. So here the marginal utility or the additional utility was 10, then it reduced to 8. It will keep on reducing. Okay. Now, because of this, you get something which is called as point of satiation, or in other words, the point of maximum satisfaction. It's called as the point of maximum satisfaction. Okay. Yeah, I keep on decreasing. There will be a point at which the marginal utility is 0. Okay. Which is basically if I consume more, the total utility will start falling. So the point of maximum satisfaction is basically the point at which the total utility, I'm writing it as TU, is maximum. There is only one product or commodity which does not follow this rule. Which is that product or commodity?
Money.
Sorry, Tom?
Money.
Very good, money. So the only exception to this rule is this rule, not the full rule, sorry. Only this rule, money. There is the concept of diminishing marginal utility in case of money, but there is no point of maximum satisfaction in case of money. Okay. As you have more, you will still want more. Okay. So money is the only exception to the rule. Okay. One more thing we did in this, something which were called as indifference curves. Does anyone remember what were indifference curves?
Yeah, indifference curve is a point at which the utility is safe along the indifference curve.
Very good. Indifference curve is basically the various point or the curve, okay, at which the utility is the same throughout. Okay, it's same throughout the curve. So I'll give you an example. Let's say I have two goods. good X, which is along the X axis, and good Y, which is there along the Y axis. Okay. So let's say I have an indifference curve. Let's say here I have more of Y. Let's say I have 10 of Y and 2 of X. And here I have, let's say, 6 of Y and 5 of X. Okay. I will be indifferent between these 2 points. If you give me any of these 2 consumption, I will be indifferent between them. Whether you give me 10-2 or whether you give me 6-5, I will still be indifferent between the two. Okay. Can anybody tell me why does it slope downwards? Why did I draw an upward sloping curve? And why does it slope downward?
It is, yeah, that is because when you increase some one quantity, it will go corresponding decrease in other quantity.
But the corresponding decrease in other quantity will be
Negative, no?
okay. Yeah, Manav, you are saying something?
No, I was saying that as in when you increase the consumption of good X, the good Y would decrease, but at a higher rate because of you getting more utility from the initial consumption of good X than from
Perfect.
good.
So this concept is called as DMRS, which is diminishing marginal rate of substitution. Initially, I will be very willing to substitute good Y with good X. But again, because of it stems from the diminishing marginal utility only. But once, so let's say for the first unit of good X, I will be okay to go ahead with 4 units of Y. But for the second, I will let go lesser and lesser. Okay, and hence the curve slopes downwards and then becomes plateau. Beyond a point, I will say, boss, no more substituting X with Y. This is enough. Okay. So the diminishing marginal rate of substitution stems from DMU only. It basically says as you consume more of one good, you will want to replace it with lesser of the other good. Okay. Fourth point that you guys studied is something which is called as the budget line. Now, what does the budget line tell you? Budget line basically tells you how much of goods can you buy or can one buy based on his current income. So again, if I have good X and Y, this is, let's say, my budget line. If entire money is spent on Y, this is the amount of goods that I can buy. If entire money is spent on X, this is what amount of good I can buy. Okay. And along my line are the various combinations of X and Y that I can buy with the budget that I have. Okay. Now, guys, what will happen to the budget line if income increases or decreases? What do you think happens to the budget line if income increases or decreases?
It will shift towards the
It
right
will
if
shift
it
to
increases.
leftwards and rightwards. No? It will go to the rightwards and then leftwards.
So if
Decrease.
increase, it will move right. So let's say this is an increase in budget. So increase in budget. If there is a decrease in budget, it will move leftward. I will be able to buy lesser amount of goods. It's a decrease in budget. So increase or decrease in budget basically shifts the budget line. What happens to the budget line when the price of one or the other commodity increases? One of the commodity increases.
It will tilt. It will fix that point, and then it will tilt towards it.
Very
It
good.
will-
So let's say this was my original price of X decreased. So I will be able to buy more of X, but the same unit of Y. Okay. So what will happen? The point Y will remain the same, but as Matthew mentioned, point X, I will be able to consume more. So it will go towards more. Okay. So this is price of good X decreasing. So basically a change in price changes the slope of the budget line. Cool. So now we have studied indifference curves. We have studied budget line. Okay, now let's see how, which is the main aim of the utility theory, is how to find the point of maximum satisfaction given the budget constraint. Within your budget, what is the point which gives your maximum satisfaction? So what do? I basically draw multiple indifference curves first. So let's say I call this as IC1, IC2, IC3. Let me ask someone else now. Ria, which indifference curve will you select ignoring budget? Is IC1 combinations better? Is IC2 combinations better? Is IC3 combinations better? And why?
For maximum satisfaction, without seeing the budget line, we would be using the IC3, which is the highest indifference curve.
Perfect, because I will in IC3 I will always be able to afford more units. So the more rightward I go, the better it is. That will give me higher satisfaction. Okay. Now, if I introduce my budget constraint, okay, let me introduce the budget constraint. Let's say this is my budget line. Pardon my drawing. It's not as neat. Let's say I draw this as my budget line. Okay, so this is now which I will be able to afford.
The tangential point.
IC.
IC1
IC1 and
IC1.
so IC1, and within IC1 only the tangential point.
Yeah.
Why the tangential point, guys?
The slope of the IC curve equal to the slope of the budget line.
Very good. The slope of the curve, IC curve, is equal to the slope of budget line. Guys, mathematically ये क्या होगा? Can you tell me mathematically? This is what we are talking entirely logic. If I talk about maths, what is the slope of a line in maths?
Y is equal to, if it is Y is equal to mx plus C, M is the slope.
M is the slope, okay. But how do you find M practically? You
dy by dx.
yes. So basically, when I say the slope of the indifference curve, I basically mean the derivative of the indifference curve. And when I say slope of the budget curve or the budget line, again the derivative of the budget line. So it basically means at the point of tangency, the derivatives of both are equal. Okay. And when I say the slope of the indifference curve, it is the marginal utility of X with respect to marginal utility of Y. And when I talk about the budget line, it is the price of X by price of Y. Everyone clear, guys? So the whole aim of utility theory is this, to find the point of maximum satisfaction given the budget constraint. ये जो भी चीज we studied or you guys have studied in economics is with an aim of finding this point. Everyone clear, guys? Fatima, Bhavani, Hans. Cool. Anto with me, right?
Yes, sir.
Okay. Cool. Now we will study how does this entire thing apply in a financial setting. Okay, so now we get introduced to introduction. The first important thing is that we already discussed. So I'll talk economics. I will talk finance. So the first important piece of distinction is what we already did. In economics, we had a consumer. In finance, we have a investor. The second thing in economics, we had a consumption bundle. Okay, consumption of goods X and Y. And or good Y. Okay. In finance, we will have an investment option. Okay. This investment option will have uncertain returns or uncertain payoffs. इसको gamble भी बोलते हैं. It is also called as a gamble. Okay, why it is called as a gamble? Because it has an uncertain payoff. More sophisticated language calls it an investment option. More loose language calls it a gamble. Okay, so I am an investor which is faced with a gamble. Okay, and यहाँ पे our aim was to find the point of maximum satisfaction. So point of max satisfaction. Okay, यहाँ पे भी we will want to find the point of maximum satisfaction. Okay, but यहाँ पे we will say that the point of is a function of wealth. Okay, so the point of maximum satisfaction will be a function of wealth or a function of money. Everyone with me, guys?
Yes.
Yes,
Clear
sir.
now? Anyone has any questions before I go ahead? Cool. दूसरा चीज यहाँ पे we were maximizing the absolute utility. Why? Because there was no probability. Here we are looking to maximize the expected utility. Why does expectation come in the picture? Guys, because there is an uncertainty. So when I say an uncertain payoff, there will be some probability associated with the payoff. So I would want to maximize it on an expected basis. Everyone clear? So let's go ahead. Yeah, let me know if you have any questions. Then I go ahead.
Yes.
Okay. Now the first thing, let's understand what do you mean by this function of wealth. So we define utility as a function of wealth or money that an individual has or has gained. Cool. So from now on, we will give this a notation of U of W. Okay. So utility of wealth. Okay. Now the point is this utility function must satisfy certain basic characteristics. So U of W, whenever I make a function of wealth, must satisfy two basic characteristics. The first thing that it must satisfy is the principle of non-satiation. In other words, the utility must always be an increasing function, which we all agree because we just discussed that only exception to the rule of point of maximum satisfaction was money. Okay, and we are talking that utility for an investor is a function of money. So whatever function we design must always ensure that it is an increasing function. How do you ensure, guys, mathematically that a function is always increasing?
U dash t is greater than 0. U dash w is greater than 0.
Very good. The first derivative of the function with respect to wealth is always greater than 0. So when I write the function uw, okay, let's say the function is a square function. So w square. When I take the derivative of this u dash w, it becomes 2w, which is basically greater than 0, assuming w greater than 0. This is an example of an increasing function. मतलब क्या हुआ? If I basically means as w increases, u of w will also increase. So if I'm plotting this on a graph, I will always get an upward. So uw is my y-axis, w is my x-axis. I will always get an upward sloping curve. It cannot be downward sloping, or it cannot be a flat line. It always has to be greater than 0, because if it is less than 0, then it basically means as w increases, utility decreases. There is no person on earth who will want that if his wealth increases, his utility decreases. Or if w increases, utility remains constant also, that will also not happen. Even if the Mukesh Ambanis of the world will always want the wealth, their wealth to increase. Everyone clear?
If it is log w means
Still
1 by 1
one.
is
So
greater than
if
0.
it's a log utility function, so uw is basically ln of w. So when I take the derivative, it will become 1 by w. Is 1 by w greater than 0? Yes, it is greater than 0, because w is greater than 0. So again, as w increases, u of w will increase.
Then u cubed 1 by u cubed.
U cube, sorry, I didn't get that. It's a
1 by
function.
u raised to minus 3.
As soon as you say
W is to minus 3.
w raised to minus 3, this creates a problem, because when I take the derivative, is minus 3 w raised to minus 4. This basically means this becomes negative. This is a decreasing function. As w increases, function will decrease. This is not allowed. Any function where u dash w goes less than 0 is not a utility function which an investor will want, or which will investor will ever portray. Cool? The second characteristic, we all agree now that it is upward sloping. The second characteristic talks about the type of slope, based on which there are 3 types of slope possible. First type is where it is an upward increasing line passing through the origin. So it's a straight line. Second type is where it is not a straight line. It increases at an increasing rate. So it goes something like this. Okay, so this is an increasing rate. This is a constant rate. And the third type is where it is upward sloping but at a decreasing rate. So here it is increasing but at a decreasing rate. Okay, so this is a decreasing rate. Yeah, if I everyone clear here when I say a slope. Okay, a slope may be a constant slope, it may be an increasing rate slope, or it may be a decreasing rate slope. As W increases, so यहाँ पे क्या हो रहा है? As W increases, U of W is increasing proportionately. As W increases, U of W is increasing at an increasing rate. As W increases, U of W is increasing but at a decreasing rate. Whom shall I ask the question? Bhavani, what do you think an investor will exhibit increasing rate, constant rate, or a decreasing rate, and why?
Sir, an investor can choose the increasing rate
Okay, why do you feel that?
because the value increases. So
Okay, so let's say Bhavani, you are there, and there is Mr. Mukesh Ambani there. Bhavani will get excited with a wealth addition of 10 lakhs. Will Mukesh Ambani get excited with a wealth addition of 10 lakhs?
no, sir.
What does that mean?
The
Okay. Go ahead, try.
Shall I answer?
No, let her try once. If not, then I'll come. Yeah, Bhavani. Give it a try at least.
the satisfaction level is different for different people.
Yeah, but what is happening as wealth is increasing, the satisfaction level is?
It is also increasing only, like
It is increasing, but at a decreasing rate, right?
decreasing rate. Yeah.
Yeah, so the level of satisfaction that I derive from an addition of wealth is very different from what Mukesh Ambani derives. I'll be very happy with a 5-10 lakh addition to my wealth. But Mukesh Ambani will say, no, okay, it's fine. So basically this highlights as wealth increases, U of W increases, but at a decreasing rate. It never flattens out. It will keep on increasing. It will never be flat, but it will keep on increasing. Okay.
Okay, sir.
Okay. So practically this is called as risk aversion. This is basically a risk averse investor, which is what we typically assume. Mathematically, this happens when the second derivative is less than 0. So the first derivative has to be positive. The second derivative has to be negative because the first derivative will ensure that it is increasing. The second derivative will ensure that it is increasing but at a decreasing rate. Okay. This is called as where it is constant is called as a risk neutral investor. Okay, here the second derivative is equal to 0. Okay, this is called as a risk seeking investor, risk seeking or risk loving. And here the second derivative is greater than 0. I'll give an example of a mathematical function. So first log. So let's say the utility function is a log of W. So when I take the first derivative, it is 1 by W. 1 by W we all discussed is greater than 0. But when I take the second derivative, it becomes minus 1 by W square. Correct? This becomes less than 0. So this is an example of non-satiation and risk aversion. Okay. Then if I talk about risk seeking, So let's say if I say u of w is w square, the first derivative is 2w, the second derivative is 2, both of which are greater than 0. So this is an example of a risk-seeking investor. Okay. The third, here if I say u of w is w only. Okay. So the first derivative is 1, which is basically greater than 0. And the second derivative is 0. This is an example of a risk neutral investor. We will always assume that the investor is risk averse. Okay, and also has the principle of non-variation. So whenever we make a utility function, whatever function we make, we need to ensure that the first derivative of the function is greater than 0 and the second derivative of the function is always less than 0. Both have to be satisfied simultaneously.
For risk aversion, no?
For risk aversion, practically everyone is assumed to be risk averse. There might be, so over longer periods of time, Tom, everyone is risk averse. There might be some specific periods of time where one may be risk seeking or risk loving, but over longer periods of time, every individual is a risk averse individual.
It all depends on the initial wealth, right?
Yes, yes. But it depends on the initial wealth. But yeah, long periods of time, we always assume that there will be one person who's able to amass decent amount of wealth. Everyone with me? Hansraj?
Yes, sir.
Clear
Yes.
now?
Yeah.
Okay. So guys, we have defined risk averse, risk seeking, and risk neutral based on the relationship between W and U of W. Okay, we will do one more definition of risk aversion. Okay, so this is what we will do one more definition. So alternative definition based on risk and return of these three types of investors. Okay, risk averse, I'll put it below only. यहाँ पे risk seeking था, तो risk seeking, risk neutral, and risk averse. Okay. So, in terms of risk and return, I will give the definition of risk neutral. So, if I'm a risk neutral investor, I will expect the return to increase in the same proportion as risk. So if risk increases by 1 unit, I will expect the return also to increase by 1 unit. If risk increases by 2 units, I will expect the return also to increase by 2 units. Okay. Kaustubh, what it will be for risk seeking? Kaustubh, you're there?
Yes, sir.
Yeah. What do you think will it be for risk seeking? Return to increase in the same proportion?
No, the return increasing rate would be higher than normal.
For a risk seeking investor?
Yeah.
What will it be for risk averse?
I think it would be constant.
Constant already risk neutral hai. Same proportion. Or a constant proportion.
Maybe reducing.
Okay. Okay. Anyone wants to add? Manav?
So it would be less proportion in risk seeking and more proportion in risk averse. So the
Could you
return.
elaborate why, Manav?
So because in risk seeking, the person would be willing to take more risk in return for a lesser reward than the
Very
risk he's
good.
taking.
Very good. Yeah. So risk seeking basically means I like risk. Okay, I like risk. Since I like risk, I will be okay for return to increase. Guys, return must increase. I will never want the return to decrease. I am risk seeking, not a fool. Okay, so return to increase, but at a lesser proportion than risk. So risk goes up by 1 unit. I am okay if the return goes up by 0.8 units or 0.5 units. Return cannot decrease. And when I am risk averse, I basically mean I dislike risk. I don't like risk, which is what practically things will be. Return to increase at a very high proportion. Very is not the right word. High proportion than risk. So if risk goes up by 1 unit, I would want the return to go up by 1.5 or 1.8. Okay. So again, if I draw this on graphs, guys, appreciate I'm changing the axis. X axis is risk, Y axis is return. Here it will be a straight line because I'm okay with the same proportion or a constant proportion. Here you want the return to increase. So it will go an upward sloping. And here you are okay for the return to increase, but at a decreasing rate. So downward or upward sloping, but flattening off. Guys, appreciate when I define in terms of risk and return, the diagram changes. Where this is the definition based on W and U of W. This is the definition based on risk and return. Everyone's understood this now, so we will not get confused. We will see what sort of things are there in x-axis and y-axis and accordingly decide. With me?
Yes, sir.
Yeah. Please, others, give me a confirmation that you've understood. Kaustubh, understood now? Cool.
So
Okay.
I have a question regarding
But
this. Yes. So if so if the risk will be less proportional, so which means if we are putting $1, we're getting 0.8. Isn't it like you're taking less risk?
no, risk is increasing. You say risk is increasing.
Yes.
Okay, risk increases by 1 unit.
Yes.
You, in order to enter into the gamble or enter into the investment, you will not be satisfied that by okay, okay, risk gaya increases by 1%, return should also increase by 1%. You will say return should increase at least by 1.5. Only then I will enter.
Exactly.
Clear? Or in other
Yeah.
words, if risk decreases, you value a decrease in risk more likely if you're a risk investor, risk averse investor.
Okay.
Cool. Okay. Now, guys, there are gambles, and I'll ask each one of you a question, and this will be the last exercise for today. So, what do I call a gamble? We just discussed that whatever has an uncertain outcome is called as a gamble. Okay. Practically, gambles are of 3 types. Fair gamble. A fair gamble is where the expected payoff is equal to 0. I'll give an example. Heads, I win 1. Tails, I lose 1. When I calculate the expectation of this will be half minus half, 0. So this is called as payoff. This is the probability. This is payoff into probability. And when I add it, I get 0. Second is better than fair. Better than fair gambles are basically those gambles where the expected payoff is greater than 0. Heads, you get 2. Tails, you lose 1. The probability is half. So 2 into half is 1. This is minus half. So your expected payoff here is positive. And then you have unfair gambles. Here, the expected payoff is negative, which is heads, I lose -2, tails, I win 1. So when I multiply this by half, this is -1, this is plus half, and I have a negative payoff of half. Okay. Now we'll have one person answer. We start with Manav. Manav, a risk, it's a multiple choice, a risk-seeking investor, according to you, one, will always gamble. Will always accept an unfair gamble. Will always accept fair gamble. Or D, will never gamble. What, according to you, is the answer to this?
Sir, I'm confused between A and B, that they'll always gamble and they'll always accept an unfair gamble.
Who
But
will accept an unfair gamble, guys? Do you think anyone will accept an unfair gamble?
Never, because it's negative always. No?
Yes, yes. Manav, unfair gamble basically is a case where risk is increasing by 1, but return is decreasing.
yes.
Nobody on earth will accept an unfair gamble. If he accepts an unfair gamble, he's a fool.
Hmm.
तो always gamble भी नहीं आएगा, because always gamble का मतलब क्या होता है? There is no one again who will always gamble.
Yes.
Never gamble भी नहीं आएगा. So a risk-seeking investor will always accept a fair gamble.
Hmm.
Am I clear? Hansraj, understood? Bhavani?
Yes, sir.
Yes, sir.
Cool. Bhavani, you give a shot to the next one. Sorry, guys, I have a habit of asking. Don't feel. I have a habit of asking because you guys start thinking. Risk neutral investor. 1A, always gamble. Always accept a fair gamble. Always accept a better than fair gamble. Never gamble.
Sir, is it always accept a better than fair gamble?
Why?
Because he is neutral, so he wants a fair gamble, but if it is better, so he would go for that. So I
Yeah,
think
he wants a fair gamble. Nahi. The fair gamble is basically a point of indifference for him. When I say point of indifference, he may or may not, but here the word is always. A risk neutral investor may or may not accept a fair gamble, but he will always accept he will always accept a better than fair gamble. ये दोनों तो obviously wrong है.
You will never
Yeah.
gamble, no?
Okay, sir.
No, risk neutral investor, nobody will never say no to gambling. It all depends upon risk and return, Tom.
Accept a better than fair rank.
Yeah, he'll always accept better than fair. A fair gamble for him is a point of indifference. He may or may not. So the
That
answer
means
always
he
here
will
is
not lose it. That means he will not lose it.
yeah. On an expected basis, a better than fair gamble does not mean a person does not lose money. It is just that there is a high probability of him winning money. I mean, the notion of expectation and actual is different. Cool. We come to the last one. Risk averse. Risk averse investor will, let's say, never gamble. Will always accept a better than fair gamble. Always gamble. That's a D, none of the above. Kaustubh, give it a try.
None of the above,
Why?
because he doesn't want risk at all.
Okay. So you'll never gamble, na?
Never gamble would also be right. I think none of the above would be more relevant.
Why? But never gamble. So, Kaustubh, you will never invest in stock markets. You are a risk averse guy.
Yeah.
You'll never invest in stock markets.
No, I can invest, but
When will you invest? When the odds are in your favor.
yeah.
Correct. So
Yes.
it's not necessary that you will always. You may or may not accept a better than fair gamble. It will depend upon the odds and the amount. So the
Yeah.
here again the word always is creating a problem. If instead of risk averse investor may or may not accept a fair gamble better than fair gamble लिखा होता तो right था.
Yeah.
Because it will depend the odds on the game.
Yes.
Am I clear?
Yeah.
So if we have to conclude, a risk-seeking investor will always accept a fair gamble. A risk-neutral investor will always accept a better than fair gamble. A risk-averse may or may not accept a better than fair gamble. It depends on the odds during that for him to decide what to gamble on. Everyone clear here, guys?
Yes.
Important, huh? This thing needs to get cleared in your brain.
Risk averse investor depends on his initial wealth,
Sorry, Tom, come again.
If he is risk averse investor, he has enough wealth, then he will accept a gamble, no? Or he has enough buffer.
It will depend, Tom. Matlab, it depends on the gamble. So let's say I give you a case where the probability of you losing is very less and the probability of you winning is very high. You will still gamble even if you have decent amount of wealth or lesser amount of wealth. It depends on the odds. It only does not depend on the level of wealth also. Clear?
Yes.
Cool. Okay, so I still have time. I'll complete one more piece of theory. A lecture is till what time?
10:50.
Oh, then we are done. Then let's complete it.
10:40, no?
50.
50. Okay, I
Yes,
thought
yes,
10,
50.
15. Okay, I thought 15. So then let me complete the utility axioms. Okay. Now we come to what we call as utility axioms. What are these axioms? These axioms are basically statements which we assume to be true. they may assume, I mean, they may appear obvious. मतलब कोई अगर, when I write the statement, you will say, sir, this is the obviously true. But the reason we are saying that these are assumptions, because the reason we are saying this, because we assume utility to be measured. So we basically say that utility is measurable, and since it is measurable, it should follow these basic laws. The first is called as measurability, which I already said, which basically says that utility can be measured. So if I have gambles, I will be able to measure, or I can also rank preference. So let's say I have gamble A, I can say that I prefer gamble A over gamble B over gamble C. I can measure the level of utility that is there. Second is called as transitivity. Transitivity. Sorry guys. The second is called as transitivity. If A is preferred over B and B is preferred over C, then A is preferred over C. Again, very, very obvious. We say that utility follows this. Okay. The third axiom is called as independence. Okay. If I am indifferent between two outcomes, two certain outcomes. So let's say I'm indifferent between A and B are certain outcomes, guys. They are not gambles. So I am indifferent between two certain outcomes, A and B. Then I am also indifferent between a combination of a certain outcome and a gamble. So P into utility of A into 1 minus P into utility of C, again P into utility of B plus 1 minus P into utility of C. I am also indifferent between these two, and here there is P is a unique investment or a unique proportion in A and B, and C here is a gamble. So if I have indifference between two outcomes, I will also have indifference between a combination of the certain outcome and a gamble, but that combination will be having a unique proportion of investment. Okay, this is called as independence. Okay, the final one that you have, D, which is called as certainty equivalence. Which basically says that if I prefer A over B over C, if I have this case, then there exists a unique probability P such that a combination of A and C will be always equal to B. So if I have three cases where basically A is preferred over B, B is preferred over C, then there will be a unique combination of these two which will ensure that I equate to B. Okay. Always this will happen, and we will say that here B is the certainty equivalent.
So can you please explain again? I didn't understand what the certainty equivalence means.
So certainty equivalence basically says that if I have three gambles A, B, C, I'm preferring A over B, B over C. Okay, then there will be a unique combination of the extremes which will equate the central point. I can enter 10% in A, 90% in C, which will equate to B. Or I can invest 90% in A, 10% in B, which will equate to C, equate to B. There will always exist this case. So if you have three gambles, a unique combination of two will be equal to the middle one.
Okay, so that okay.
And there will always be such a combination that exists, is what you mean by certainty equivalence. All of these guys are very, very obvious statements. Okay. The reason you are making these statements because you are trying to quantify an unmeasurable quantity. Hence, you are saying that if I am measuring this, it will follow certain basic rules of mathematics. Am I clear?
So in the transitivity, it is necessary to one to be greater than the other.
Yes. मतलब ये logic है ना कि basically let's say I am preferring what I prefer Ria over Hansraj. Okay. And I prefer Kaustubh over Ria. So that basically means I prefer Kaustubh over Hansraj. Sorry, this is just an example, but there's no preference. Ria, clear, na?
Yes, so preference is important.
Yes, you assume the first thing, which is basically you're preferring. So I mean, I like Reliance over Infosys. Okay. But I like TCS over Reliance. Basically means I'm preferring TCS over Infosys as well. Clear, Ria?
Yes, yes.
Cool, guys. I think I have done enough for today. Okay. What I'll be doing is, guys, revise this and come, especially the aspect of risk and return. Then I will move on to something which is called as absolute and relative risk aversion, and then we go on to utility functions. Okay. So next lecture I will go ahead with some parts. I'll get on to some mathematics, and उसके बाद वाले lecture में मेरा खत्म हो जाएगा.
So I just didn't understand the independence also.
Okay, cool. Independence भी basically क्या बोल रहा है? If I have, let's say मेरे पास दो FD है, ये ICICI बैंक की FD है, ये HDFC बैंक की FD है. Let's say I am indifferent between these two. These are FDs. Then a combination of ICICI Bank and Reliance and a combination of HDFC and Reliance will also exist where I'm indifferent. Clear? So ICICI Bank plus some share plus HDFC Bank plus some share. FD. So दो FD है, I'm indifferent between those two. There will also be a combination of FD and a share that I will be indifferent with. Clear?
Yes, so this A and B are certain outcomes.
Certain outcomes मतलब they cannot change. उनका outcome change नहीं होगा. FD में कैसा 100 रुपए डाला तो एक साल बाद 107 मिलेगा ही. So that is something like that. They are certain outcomes.
Yes.
Am I clear?
Yes, yes.
Cool. Cool, guys. We are done for today. I think we are going to meet one more time this week, and then by the 27th I'll be done. So I'll require 2 more lectures to complete this chapter, and then you'll have the entire practice question to be done. Huh? So by early next week I will be done with this chapter. So next week you will have the practice questions of this chapter coming for you. Any questions? Shall I end it?